I like talking about process, so let's go through and look at this problem as though A through E were not sitting on the page in front of us, because your unit assessment of a linear programming problem won't. So I'm going to take this apart and write out some things as I encounter them and process or share with you my process. So here we go. The profit. Well, again, most every linear programming problem is going to have to do with maximizing profit, minimizing costs, or minimizing resources. So a manufacturer of ski clothing makes pants and jackets. The profit. So profit. The profit on a pair of pants is $2. Well, that sounds relevant. Maybe I ought to write that down. And on a jacket is $1.50. Well, if they were both $2, we wouldn't have to go through this. It wouldn't make any difference if they both had profits of, $1.25. It doesn't make any difference which one you make. They're both going to generate the same profit, but here we don't. And that's kind of a clue when you're going through and solving this problem. So let's go through and look at the idea that we're going to be concerning ourselves with profit. So we're actually going to write that down. The profit that is generated by this is, well, for every pair of pants I make, I'm going to get $2. And plus sign means and. For every jacket, God, this could take a while if I have to draw every single thing. A jacket is going to give me $1.50. So that's my number one thing. I have three unknowns. I don't know my profit, I don't know the number of pants, and I don't know the number of jackets. Well, that doesn't get me anywhere. I can't solve it quickly, so I need more information. So let's go through and find some more information. Both pants and jackets require the work of sewing and cutting. There are 60 minutes of sewing. Well, let's put that down too. A sewer can give me 60 minutes. So let's put that in there. Sewer needs 60 minutes. Or a sewer can give me 60 minutes. Let's read it. There are 60 minutes of sewing operator time. Well, that tells me that the sewer can only say, here's 60 minutes. You give me one jacket, you give me 50 jackets, but I'm only going to be able to give you 60 minutes. So that's a limit. That is a constraint. So let's bear that in mind. And then here we've got 48 minutes of cutter time is available. Okay, so let's write that down. Here for a sewer, I know that I've got 60 minutes, and for a cutter, I know that I have 48 minutes. Now, what can they do with their time? Well, it takes 8 minutes to sew. So I'm going to go back up here to the top. It takes 8 minutes. Let me make this a little bit smaller writing and change the color just a little bit. Here we go. 8 minutes to sew a pair of pants. So it takes 8 minutes to sew a pair of pants. Isn't that what it tells me? 8 minutes, sew a pair of pants. Yep. And 4 minutes to sew a jacket. I really wish there was some way that I could write this without having to draw a jacket and a pair of pants every single time. That would just be really lovely. Maybe I'll think of something here in a minute. All right. So let's make this jacket look a little bit more believable. There we go. Zipper goes up the front. All right. So that's 4 minutes to sew one jacket. Cutters take 4 minutes on a pair of pants. Okay, so right away I'm seeing a difference. 4 minutes for a pair of pants. And, that's a fun word because it means plus, 8 minutes on a jacket. So 8 minutes on a jacket. Thank heavens I'm not teaching art. Okay, find the maximum profit. So maximum profit, that's kind of our thing. Again, this is linear programming, so that's not terribly unusual. maximum profit and the amount of pants and jackets to maximize that profit. Well, if we're talking about maximizing profit and the amount of pants that are needed, then doesn't that kind of say that, hey, the thing that you're looking for is you need to know how many of those, and you need to know how many of those. And if I look at the other work that I've done, I still don't know how many of those and how many of those for each one of these either. So this problem is going to be focused on a variable concentrating on the number of jackets and the number of pants. So let's shrink this down and push it over to the side a little bit. And now let's try and convert all of these drawings and words and things into math speak. All right, so here we go. Looking at the profit, since that's really what this problem seems to be focused about. Well, first of all, wouldn't it really help if we were able to not have to draw pants and jackets every time? So we're going to steal a look down here because I don't want to mess up the A through E. Let X be a pair of ski pants and Y be a pair of jackets. So I can go over here and say a pair of pants is X. Whoops. There we go. A pair of pants is X and a jacket is Y. So if that's kind of where we're headed, then let's look at setting up our profit equation. I mean, that kind of is the answer. We want to get out of this problem quickly. So profit is going to be $2 for a pair of pants. And the question is, how many pants can I make? And profits is in dollars. So I've got $2 for every jacket. And I get $1.50. Excuse me, $2 for every pair of pants and $1.50 for every jacket. That's three variables, 1, 2, 3, X, Y, and profit. I really am going to have a very challenging time trying to solve a problem for three variables. So let's get some information that can help us solve that down further. A sewer can do in 8 minutes a pair of pants, and a pair of pants is X. They can give me 4 minutes to sew a jacket, and a jacket's Y. And they have a total of 60 minutes. In the case of the cutter, a cutter can do 4 minutes, or cut the material for a pair of pants in 4 minutes. And they can cut the material for a jacket in 8 minutes, but all the time they can give me is 48. So let's think about this, all the time they can give me. That sounds like an inequality. And it sounds like an inequality because I realize that I haven't told you or them or anybody yet, I need 5 jackets made, or 10 or 30, or I need whatever. They're telling me I can give you at most 60 minutes of sewing time or 48 minutes of cutter time. How can I put that into an inequality? So let's assume something kind of ridiculous. Let's say that for my sewer, this very first equation, I have them sew 0 pants and 0 jackets. Well, that's fine. They're still sitting over there for 60 minutes. So which way would the inequality go? That way or that way? Which one of those is going to be bigger? Well, as I look at this, it's just intuitively, I should be thinking, hey, I'm going to be looking at the maximum that I can do is going to be 60 minutes, and that would be a reasonable equation. So that's the way that I see it. If you see it differently, please share it out in class. And the same mentality works over here. If I give the cutter no pants to cut material for and no jackets to cut material for, and they can give me 48 minutes, then I know that the inequality goes that way. And looking at the words, it says that there are 60 minutes of sewer operating time. Well, the way I've written it out in green, it says that if I give them 0 pants and 0 jackets, that will be less than 60. The words, however, there are 60 minutes of sewing time available. So I can change this a little bit to be also equal to. So the number of pants cut for and the number of jackets will be less than or equal to 48 minutes. So I've got a couple of inequalities. So let's go through here and maybe we'll just erase this. Can I erase the black at this point? No, it's been there too long. One of the limitations on this program is how much I can change. So let me just, I'm going to write less than or equal to, and up here, less than or equal to. And I'm going to erase that stray mark. So right now I've got a couple of inequalities, and I still don't know how many pants and how many jackets, but I think it would probably help me if I go through and graph these. I feel very comfortable with where I am, and I'm going to try some test points just to see if it works. So I'm just going to take on the first equation. I've put in a graph, hopefully which will make things a little bit easier. At least they do for me. Again, this is my process. It doesn't have to be yours. So for a sewer, why is my pen not working? There we go. For a sewer, my equation is this one up here. And I want to put that in y equals mx plus b. This is just the way I process better. So I've got 8x. You know, I'm going to make that a little bit smaller pen tip. There we go. Okay. 8x plus 4y is less than or equal to 60. So putting it into y equals mx plus b, let's subtract 8x from both sides. And I'm left with 4y is less than or equal to negative 8x plus 60. Now I can divide everything by 4. I'm not going to use a calculator, so 4 divided by 4, 4 over 4 is just 1. So I've got 1y left, and without putting a coefficient out front, that means that the 1 is understood, is less than or equal to. 8 can be divided by 4 into 2. So I can lose the 8, and then the 4 becomes 1. So negative 2x plus 60 divided by 4. 60 divided by 4. 4 goes into 6 once. 1 times 4 gives me 4. 6 minus 4 gives me 2. Bring down the 0, and 4 goes into 20 exactly 5 times. So I've simplified that equation. And I'm going to put it back up here at the top that y is less than or equal to negative 2x plus 15. And I can go ahead and probably, hopefully we can erase all this stuff. Yep. And we can go through the exact same process for the other one. Actually, this is easy math for you, so I'm going to pause here and just get it for you. Okay, so now we've got our two equations. And since most of you have already learned y-intercept and the slope-intercept form, here I've got two y-intercepts. One of them is 15, the other one is 6, so my scale should be fairly straightforward. I know that it's going to intercept at 15, so I'm going to say that that is 5, this is 10, and that's 15. That's on my y-axis. And one of these intercepts at 6. So I'm going to put a 6 right here. That would be my cutter. And up here is 15, and that's going to be my sewer. And they both got negative slopes. Now, one thing you're probably going to figure out, hopefully with time, is that on any kind of a graph, that is a negative slope, and this is a positive slope. And that's just the way it works. You will notice it with a pattern eventually. Do you have to memorize it? No. But look at my posted SAT question in class and you'll see that it can be very helpful. YouTube frowns on anything longer than 15 minutes, so I'm going to stop this one here and I will upload part 2 in a minute.